Solving equations, they call this thing the uniqueness property. In different books they call it different things. And it's the idea that if you have an exponential equation, that if the bases are the same, then the exponents, it implies that the exponents are equal. Can't say that if the bases are not the same. So base is the same means exponents equal. Now, some of this, and I kind of think about how it goes, some of this, bottom line, you're going to stick into, we've got so many pieces of technology now, far beyond your graphing calculators, that can do some of this stuff for you, right? But when you get into certain areas, it becomes a simplification process that you need to do before you can put it into the entity that's going to actually do the work for you. So that's some of the learning process that comes along here. The example is, it says, suppose you want to solve 2 to the 3x minus 5 equals 16. The first question I ask myself is, can 16 be written as 2 to some power? Well, the answer is yes. 16 ends up being 2 to the 4th power. And I think I do have an extra powers tables that my intermediates use when where we're working on radicals right now. That would be helpful to you. So that says I can write this as 2 to the 3x minus 5 equals 2 to the 4th. So now the bases are the same, so the exponents are equal. Then you solve for x, and then you can check your answer. That is the easiest way, if you can, to do the problems. Anytime I'm doing a problem, I'm looking to see, can the bases be made the same? Because otherwise it can turn into something that's more ugly.